Welcome back to the Foundry by Forge College. Let's get right into today's explainer because I am incredibly excited for this one. We are finally crossing a massive threshold. Up until now, we'd basically been gathering requirements, feeling out our needs. Today we are taking all those subjective preferences, all those heated late-night debates about how we think we should deploy our applications on Solana, and we are turning them into a concrete, undeniable engineering blueprint. So let's dive into this and see exactly how we translate theory into hard proof. Here's the architectural schematic we're working through today. First, the capstone blueprint, then we'll meet the protocols, followed by building the scorecard, doing the math, looking at trade-offs and integration, and finally, preparing for runbooks. All right, Section 1, the capstone blueprint. Let's just quickly anchor ourselves and remember exactly where we are in our Solana network selection process. So you've already knocked out step 1. You scoped your decision framework and you designed your criteria. And looking ahead, step 3 is going to be drafting those actionable runbooks. That means today, we are right here. At step 2, we're building the bridge. We have to map those criteria to our protocols so we aren't just, guessing what to ink into our final documentation. Okay, but what do we actually mean when we say mapping? Well, it's really the critical engine of our system's design. Mapping is the activity that converts your conceptual design artifacts, like those spreadsheets of weights and preferences, into actionable selection intelligence. It's the entire process of moving from, I feel like this deployment method is best, to sliding a piece of paper across a stakeholder's desk and saying, here is the objective evidence why this is the best. Section 2, meet the protocols. Because before we can start scoring anything, we obviously need to inspect the parts we're building with. And wow, there is a sheer contrast in our engineering options here. On one side, we have manual scripts. This is basically the digital equivalent of duct tape, right? Highly familiar, super fast to write, but dangerously low on reliability. Then, on the complete opposite end, we have Canary deployments. This is your over-engineered multi-stage spaceship. It is incredibly reliable, gives you that smooth traffic shifting, but it is painfully slow to deploy. It takes a lot of time to orchestrate a spaceship launch. For the sake of this explainer, we're going to keep our list of candidates pretty pragmatic and bounded. We are looking at 4 main ones: script-based manual deploys, CI/CD pipeline-driven deploys where artifacts sit in a registry, staged canary flows for traffic shifting, and finally, framework-specific flows, like relying on Anchor's native deploy commands. These 4 are going to give us a really fantastic, varied testing ground. Moving on to Section 3, building the scorecard. We know our criteria, we know our candidates. Now it's time to stress test these protocols and turn opinions into hard data. And this right here brings us to a massive engineering hurdle. How on earth do we objectively measure a subjective requirement? Like, if I ask you, hey, is this protocol observable? You might just say, sure. But that's not a metric. We have to convert an abstract concept into an observable, testable property. We literally need a ruler. So our scoring rubric acts as that ruler. We use a straightforward 0 to 3 scale. If a protocol gives us 0 metrics, it gets a 0. If it only spits out, let's say, if it just gives you basic logs, it gets a 1. If we can get metrics and traces, but we have to manually wire them up every single time, that's a 2. But if we have native metrics and traces with built-in exporters right out of the box, boom, that's a 3. By structuring it this way, we completely strip away the emotion. The protocol either has the capability or it doesn't. We do the exact same thing for upgradability. A 0 means you literally have to redeploy a whole new program ID on Solana. A 1 means you're stuck doing manual data migration. A 2 means you can use the upgradable program mechanism, sure, but there will be downtime. And a perfect 3 means you get a buttery smooth upgrade path with automated rollback hooks. Breaking requirements down into these hyper-concrete capabilities, that is the absolute secret to bulletproof systems design. Now, absolutely crucial here is something we call provenance. Think of this exactly like buying a used car. If the dealer tells you the engine is brand new, you don't just take their word for it, right? You ask for the receipts. When you give a CI/CD pipeline a score of 3 for reliability, you need to write down exactly where that evidence came from. Was it a DevNet experiment you ran? Was it pulled from official documentation? Always keep your receipts because you're going to need to confidently defend this scorecard to your operations team later. Section 4, doing the math. We've got our scores, we've got our receipts. Let's run the numbers and calculate the actual winner.
Let's pull in the weighted schema we designed back in our previous lessons. Notice how reliability is acting as our heavyweight champion at 30 points. Observability is right behind it at 20, speed and upgradability sit at 15, while cost and familiarity are at a mere 10. So this is our baseline. What we do is multiply our 0 to 3 capability scores by these exact weights to reveal the true winner.
And here is the grand reveal. When you actually run the math, the results might surprise you. Because we placed such heavy weights on reliability and observability, manual scripts completely fall flat. But look closely. CI/CD pipelines actually edge out Canary deployments in this specific scenario. Why? Well, because while Canary scores a perfect 3 on reliability, it completely tanks on speed to deploy and operational cost. The math cuts through the noise and reveals the most balanced protocol for our specific needs. Now, obviously, if you are managing a complex system, you don't want to be doing this on the back of a napkin. You can easily write a tiny TypeScript utility to automate the whole thing. The logic is beautifully simple. Iterate through your protocols, multiply the criterion weight by the protocol score, sum up the total for each, and sort them descending. This gives you a highly reproducible programmatic justification for your architecture. It takes human error right out of the equation.
Section 5, Trade-offs in Integration. All right, let's pause for a quick reality check. Because as we see all the time with developers across our other Forge College programs, getting the highest mathematical score absolutely does not mean a protocol is flawless.
In engineering, there is simply no such thing as a perfect solution. There are only perfect compromises. You must observe your trade-offs explicitly. Even if your top-ranked CI/CD pipeline won the math game, it might require your team to learn brand new tooling, or it might slightly bump up your monthly infrastructure cost. You have to document those trade-offs clearly, right next to your winning score, so your stakeholders know exactly what they are buying into. No surprises. And remember, we aren't just picking a winner for fun. We have to actually build the thing. We must extract actionable integration items. So if CI/CD wins, your ops team needs to know right away, what specific CI hooks do we need to write? What monitoring exporters need to be triggered during a deploy? What is the exact mathematical threshold that triggers an automated rollback? You have to attach these concrete integration requirements to your winning protocol right now. Which brings us to Section 6, Preparing for Runbooks, the final handoff. This is where we bundle all of this hard work into a clean, actionable deliverable. Your final deliverable, your mapping artifact, should be a lightweight, highly readable document. It needs 4 things, and literally only 4 things. The numeric scores that prove the winner, the textual evidence or provenance that justify those scores, your honest trade-off notes, and a clear list of actionable integration items. Bring those together and you have a gold standard blueprint. As you're wrapping this up, I want you to take a hard look at your blueprint and do a quick litmus test. Ask yourself, are your integration items detailed enough that a technical writer, or maybe a junior ops engineer, could extract them and build the pipeline without ever having to rerun your evaluation? If the answer is yes, you nailed it. If the answer is no, well, you need to go back and add a bit more detail to your provenance. And that, everyone, is exactly how you map deployment protocols to your decision criteria. Your very next step is going to be drafting your actual step-by-step runbooks based on this blueprint. I highly encourage you to head over to forge.college to build your own scoring utility and keep exploring more Web3 systems engineering topics. Thanks for hanging out and learning with me today in this explainer. But right before you close this out, I want you to ask yourself one thing. If you ran your current deployment pipeline through this exact math today, would it survive the stress test, or would it break under the weight of its own trade-offs? Think about it. I'll see you in the next one.